Hello everyone and welcome back. In this video, I want to talk about some graphical user interface basics and input-output streams in Java. We will talk about handling events, streams, and serialization. First of all, we have some event listener basics. In Java's GUI, graphical user interface, a listener is an object that waits for an event to occur and defines what to do when that happens. The primary role of a listener to handle events generated by the GUI. And for example, when you have a button click, it calls the action listener, and that action listener makes an action performed. For example, this slide has an animation right now, and when I click on it, you can see a button appearing. Also, same idea, there's an action listener in the JavaScript of the Google Slides documentation, and when I click it, it just listens the action, it knows there's an action, and just it knows it's performed, and then it gives me whatever I want. So the question is how listeners communicate with sources. It is called delegation event model. A GUI component, like the event source, has methods to allow listeners to register themselves. In this example, we have a button dot add action listener, my listener, and when user interacts, like clicks or types, the component creates an event object and delegates handling to all registered listeners by calling the appropriate callback method on the listener. And then, for example, this button will call action performed event, and it will be know the action has performed. And in summary, basically, the source fires an event, and listener's method executes that to respond. The listener and source usually communicate to an interface. The event object, like action event, can be passed to the listener method, carries information about that event. This decouples event generation from handling, and the GUI component doesn't need to know what happens, it just notifies the listeners. We have a couple GUI widgets and their event methods. We should know some common concepts in UI, like widgets. For example, we have button, which is called JButton, Java button. It generates an action event when clicked, and the listener interface is like this action listener. And the method to implement is action performed, which also has an argument called action event, or E for simplicity. So a button click is handled action performed. That's where your output code for should happen when user clicks on the button. And we have checkbox, again, Java checkbox, J checkbox, often generates item event that when its state changes, like checked or unchecked, the listener can be an item listener with method, and it will be item state changed. And again, we will have an argument called item event E. Using that, you can create to user ticking or unticking the box, like checkboxes. And then we have text fields, again, Java text field, that can generate action event when user presses enter while typing it. This can be handled by action listener as well, same like the buttons. Action performed method is special for the text field. It will be called when you press the enter key. And additionally, for key by key handling, the text field can have key listeners to respond key pressed or key released events. For example, when you make video games and you click on the D button, let's say to go right, or in the right arrow key, you want it to stop when you unpress the button. So we are also listening for key pressed and key released. And some other examples could include window events like GFrame generating a window event, which can also handled by window listener, such as window closing event, or slider, which can also created by change listener, and it also checks if its state is changed or not. You can also use it like to resize your window or clicking button, giving any input in your computer. You can have some event methods to handle them. Let's look at some coding examples. I am in VSCode running in WSL Ubuntu, and I already prepared some Java code. Let's say touch GUI example.java. I already created the file, so I will just copy and paste, and we will talk about it together. First, let's check if it's compiling. Yes, let's see. We will learn it later. First, let's look at the code. Here we have the main function, which is first creating the frame from GFrame, Java frame, using these three libraries. And we are going to have a size of 400 to 200 frame or window. And we are also having exit on close. If you check my maybe like Pygame window creation videos, you know that you don't, even to close the window, that arrow button doesn't mean anything unless you program it in the background. So it's important. And then we have a layout manager here. I can skip it. I just want to talk about button, checkbox, and text field. So here we have a button example, which is a JButton class object button, which comes from the JButton, and it says click me on it. And we are adding an action listener, which is checking for an action listener, and it will be performing and saying button clicked when clicked. Let's try it. Here is my GUI basic demo, which is the first one is the J button. When I click it, it is saying button clicked. If I click again, another button clicked. Basically, this is how it works. We have action listener here. We have checkbox and item listener. Again, checkbox class, check object comes from the new checkbox, and it says check me on it. And we have item listener. And again, when it happens, we will say check. Here you can see it is a checkbox. So when I click on it, we can say what is checked and unchecked. And the third type, we have text field. Again, text field class, Java text field class. And the action listener says this time when we type, it will give us you typed, whatever you typed. And you can get text, whatever was given to the text field. So this is the method to get the text. Let's go again. Here we have this button. I will say hello Java, and we typed hello Java. When we click on the close button, it closes. It means exit on close. Very important. We can just skip that. Going back to the slides, we have three ways to specify listeners. In GUI programming, there are a few ways to attach the event handling code. And the first one is the containing class implements the listener interface. For example, your frame class implements action listener, and this object is the listener. You register with the source, like for example, button add action listener, and you give it this. And the class must implement action performed for the action listener to handle this event. This is straightforward, but can lead to one class handling many events. And we need to know what we are using for. Second one, we have separate listener class. You can create a dedicated class that implements action listener or whatever listener needed. And for example, we can have a class my button listener, and the same as the function body or like class body. And then we can instantiate it with button add action listener, my button listener, which I will show in the examples soon. And third, we have we can use an inner class or anonymous inner class, and it is a very common pattern in Java GUI. For example, if we have a button action listener and we are looking for action performed, this will create an anonymous inner class implementation, which I will show in a minute. And in modern Java, we also have lambdas. It's optional, like one line function when I mean lambda. So let's go back. Let's look at our first example. First, I will create the first function class. As previously, I already created this. Here we are using Java Swing and W8 AWT events. Here we have a class called FrameWithListener, which extends Java Frame and Action Listener to showcase the first example. Here we have a J button, which says click me, like the previous example. But here we have a super, which frame implements listener. And when we call this FrameWithListener method, we also have the action performed, overriding the action performed method. And we have the main function. So let's show it how it works. And here I get my window. It says click me. And when I click it, it says button clicked via this. So as you can see, we overrided the action performed. All button events come from here. Even that we call the FrameWithListener, which is calling the action listener and getting the button. Still, it is coming from the action performed function method. The next example is we have another Java file. If I go into the type a bit earlier. Okay, first let's talk about what this does. Here we have a separate listener. In the main function, we are calling a Java frame, which says separate listener, and we are adding an action listener, which is my button listener, and my button listener is implementing the action listener, but we are overriding the action performed. And when we click on it, in this example, I press it, we are clicking the button via my button listener. We are not using the action listener that was built in. And the last example, the third one, we have anonymous inner class example. And in this example, this one we are using inner class or anonymous inner class, which is under our main, which cannot be accessed by other places. And we are basically saying button add action listener, and the action listener will be outlining that. When I say Java anonymous action listener, we have this window, and when I say click on the go, we are clicking the button via anonymous action performer. We are back at the slides. We have another example of the anonymous inner class, the same one actually. It's just under the button object, so it is inner class. It will be short and localized. And we also have layout managers. In Java, it determines how components are arranged, like the size and position, inside the container like gpanel or JFrame. Three basics layout managers to know. We have FlowLayout, BorderLayout, and GridLayout. The FlowLayout places components in a row, like left to right, and laps to the next line if horizontal. Space runs out. It's a simple layout. Components appear in the order they were added, like words on a page. And it is often used for small toolbars, groups, or buttons. It's also default for JPanel. When you use JPanel, we have BorderLayout, which arranges components into 5 regions like north, south, east, west, and center. And each region can hold at most one component. And north is the top, south is the bottom. It's often used for like headers and footers, the way website works. East is right, and west is the left side, and center is the fills whatever space in the middle. And border layout is the default for GFrame's content panel. It's good for creating top and bottom sidebars and kind of UI. And third one, we have GridLayout, which is organized components in the grid of equal size cells, like rows and columns, more like Excel sheet, but equal sized. And you specify the number of rows and columns, and every cell is the same size, and components are stretched to fill the cell. Let's look at this visual to understand the layouts better. The first one is FlowLayout. You can see they go to the flow. This is BorderLayout. We have 5 parts: north, south, east, west, and center. And we have GridLayout. We can give it how many grids we want, and it will give us in here like 6 equal grids. And we have streams in Java. Input-output. A stream is a sequence of data, like a stream of bytes or characters. And there's 2 broad categories. First one is connection streams or node streams. They represent a direct connection to a data source or destination. For example, we have file input stream, file output stream, and socket input stream. File input stream reads bytes from a file. File output stream writes bytes to a file. And socket input stream from a network socket, we just as the input, and etc. And they can stand on their own because they know how to interact with the source or destination, like files or networks. And we can think of these as the low-level conduits to some place where data comes from and or goes to. We have chain streams, also known as filter streams, and these streams do not connect directly to a data source. Instead, they attach to another stream to provide additional functionality, like chaining the streams. And for example, we have BufferedReader is a chain stream, and it wraps another reader like FileReader to buffer input and allow reading lines efficiently. Similarly, we have buffered output stream, which wraps on output stream to buffer output. And we have object output stream that wraps a lower level stream to write Java objects in serialized form. And chain streams can rely on another stream to actually receive the data. And you can recognize them because you pass an existing stream into their construction. And in usage, they often combine with another connections. Here we have an example of chaining streams. And as you can see, we have file input stream class, which is file in object, and it gets the data.txt. And BufferedReader is getting that file in object, and it gets UTF-8 because that's the common thing to use, common type of the data when we read it. And this is how chaining streams work. Let's move to VSCode so I can show some other examples. Let's say touch. And in this example, we have an IOStream example class which has a main, and it is reading from the demo txt, which we do not have at this moment. Let's create it. And let's say this is a demo file with text. It also has multiple lines to read. Okay, here we are using the demo txt to use chain streams. I will compile it quickly. Here we have output stream that is outputting the file name called demo. And we have a writer. And our writer writes using the output stream, file output stream we created using file output stream. And it is connecting to the writer. So when we say line 1 and line 2, whatever, as you can see, it did write over my existing demo. And we are reading back from the file by line. Again, here we have file input stream called fis, and we are connecting it to the reader using BufferedReader. And again, it takes our fis object, reads it, and then uses BufferedReader. And this is how it reads the file. When we look at the output, first it loads to the file name, which is demo.txt. And when reading from the file, it reads the line 1, hello world, and line 2, Java input-output streams. And we have serialization, which is saving an object state. And when an object is serialized, it is converted into byte stream for storage or transmission. What actually gets saved is the object state, meaning the values of its instance variables. The class definition, the bytecode, itself isn't saved in the stream. It is assumed the receiving end has the class definition available. So if you get a question like when an object is serialized, what has to be saved? The answer is essentially the object state, its data. This includes all non-transistent fields of the object, and if those fields reference other objects, like those objects are serialized too, like recursively, provided they are serializable, of course. And static fields are not part of any one object state. They belong to the class, so they aren't saved as part of individual object serialization. And so we don't have the static fields. And we can think of serialization as a freezing the values of an object's attribute so it can be stored and later reconstructed with the same state, which we will have examples. And we also have BufferedReader and BufferedWriter, which I just showed in the example for chained streams, which we will look at again. So we are using them for chain streams. We are wrapping on the reader or writer, but that buffer characters, we are improving the efficiency and provide convenient methods. For example, this BufferedReader has a readLine method that reads an entire line of text in one go. Under the hood, it reads chunks of characters into a buffer, which reduces the number of slow, low-level read operations. This makes reading text much faster. Our example was simple and short, but imagine you have a big data sheet you need to read. It is much faster. And similarly, we have a BufferedWriter, which buffers the output so that writes are aggregated before actually writing to the file or stream. And it also provides a new line method to conveniently insert the platform-specific line separator. And in summary, we are using BufferedReader or writer to increase input-output performance and go get higher-level read-write methods like reading lines. Let's go back to our example. Here we have BufferedWriter that writes the works together with the file output stream, which is chain connection. And we have BufferedReader, which we just used in the example. Again, it's using together with file input stream as a chain connection. I also want to talk about examples for input-output, so serialization. Let's see. Here we have a serialization example. As you can see, we have a string called ser file, which is person.ser. Let's say we have a serialization file. And we have a person called P, name Alice, age 30, which comes from the person class here we created. First look at this class. We have a serialized version of the user ID, which is a long number. We have string name, age, and we are also having ignored field that won't be serialized. That's why we call it transient. And a person has its name and age. And when we call to string, we are returning person's name and age output. Okay, coming back to the serializable object, our person name Alice, age 30. We have file output stream, which is outputting the ser file, serialized file. And we have object output stream, which is getting the file output stream we created, and it creates a new object output stream. This is also a chain connection. And we are writing an object, and will notify it to the terminal. And if we have a error, we will try to catch it, like we talked about in the previous videos. Try, catch, finally. We don't have finally, but we can try and catch if it fails. And we also have deserializing the object. And again, we have file input stream, the opposite way. This was output, this is input. And we are using object input stream class, which is again using together with the file input stream. And this time we are reading the serialized object and we are deserializing it as the person2. And then we are going to print if we been successful. If not, it will catch the error and it will say, okay, this is your error. Let's compile this and call it as an example. Okay, as you can see, first we are serializing the LSH30 and we created this file. I don't think you can see it, but yeah, you can understand some parts. We have the serialization example, person, and I see Alice. So this is not readable, but at least you can get the idea. And then after we created the person.ser file, we are reading back here. And this concludes our serialization examples. And if you go back to the slides, we just talked about this. Also, without the BufferedReader, you will have to read character by character or manage buffering manually, which you do in C. And it is not fun to consider these buffers all the time, so I like it. It's easy. We talked about event listeners and handling. We talked about graphical user interface, layout, and managers. We talked about connection and chain streams, serialization basics, and we talked about buffered reader or writer for efficient input-output. Thank you for watching. I will not continue with this series. This was the last one. I talked about Java essentials. So I don't have anything to add. Like I said, thank you for watching and see you in the next one.